Hello, today we are going to solve a numerical problem from the portion free body diagram. Okay, so we'll go into the problem. This is the problem, that is, there is two spheres, each of weight 1000 Newton and radius 25 centimeter, resting in an horizontal channel, and its width is 90 centimeter. The figure is given in the question. We need to find the reactions on points A, B, and C. Okay, so this figure is given. So we need to again draw a figure with all the dimensions. That is, we know the total base width of the channel is 19 centimeter. Sorry, 90 centimeter, and the radius is 25. So that is this distance, and distance is 25. That is marked in this base 25, 25. So 25 plus 25, 50. Then remaining is 40 centimeter. That is this center to this center. This distance between center to center of the sphere is 40 here in horizontal. Okay, so that is marked here. Next step is we need to draw the free body of this spheres. Okay, so what does free body means? Free body diagram means we need to isolate the object from the supports, right? So we are assuming imaginary supports, and we are isolating that body, and we are only marking the forces and reactions acting on that object. Okay, so here we know there are two spheres. Just now is numbers 1 and 2. Two spheres are there, so we need to draw the free body diagram of both the figure. Okay, so first I'm considering first sphere. So I'm isolating that sphere only, that and it supports, just ignoring the supports here, just only plotting the drawing the reactions on that point. Okay, so look here, the sphere is resting on this horizontal as well as this vertical plane, right? So this point where the sphere is touching the channel or the vertical or horizontal plane, there will be a reaction from that plane, right? So that reaction is drawn here as RA and RB. Okay, so RA is horizontal reaction and RB is vertical reaction. And again, this first and second sphere have a contact at the point D, right? So when there is a contact, there is automatically a reaction, right? So this second sphere is giving a reaction to the first sphere. So that is why it is marked as in this direction, it is RD. All right. And its self weight 1000 Newton. These are the forces acting on this first sphere. Again, we are considering the second sphere. In second sphere also, it is touching the vertical plane and the sphere. So there will be two reactions, that is RC and the reaction from the first sphere. That is marked here, it is RD. The reaction is coming from the first sphere is marked in this direction, and it is RD, and the reaction from the support, so the vertical plane, that is RC. Okay. So comparing these two spheres, which one have the less number of forces? We know the second sphere has less number of forces. That is, it's only RC and RD and 1000 Newton. Okay, so only two unknowns are here in this sphere. But if we consider the first sphere, there are three unknowns: RA, RB, RD. Okay, so in order to start a free body numerical problem, we should choose a object with less number of unknowns. So here we are going to start with sphere 2, because sphere 2 has less number of unknowns. So sphere 2 we are going to start. And before starting the problem, we need the angle theta, because here look, RD is an inclined force, right? So inclined force, if there's an inclined force, we need to resolve that forces into horizontal and vertical component, right? So in order to resolve these forces, we need to know the angle theta. Okay, so how we will find the angle theta? So look in this figure, we know this is the direction of RD force, right? So this is the force, and we are making a right angle triangle here. Look, we are dropping a perpendicular from E, and also we are extending a horizontal line from F, and we will get a triangle here, a right angle triangle here, and this is our angle theta. This angle, if we know this angle, we can resolve the force RD. And we know the length of FG, right? FG is 40 centimeter, and also we know this hypotenuse, right? Because it is the sum of radius of the two spheres, 25 plus 25. So we know 40 and we know 50. So we can use the trigonometric function, that is cos theta is equal to, sorry, sin theta is equal to, sin theta, this is theta, so if you use sin theta means what? Opposite side by hypotenuse, right? Opposite side is here FG and hypotenuse here is EF. So we know the value of FG as 40 and we know the value of EF as 50. So from this we can find the value of theta and we will get the value of theta as sin theta is equal to 40 by 50. So theta is sine inverse of 4 by 5 and we will get this as 53.13 degree. Okay, so we got the angle theta. So if we know the angle theta, then we can resolve RD. Okay, so first step is completed. Now we need to resolve, we need to solve the two spheres. So first I am considering the second sphere. So this is angle theta. Right, so this is angle theta. So this is the angle theta. Considering the second sphere, this is angle theta. So if you resolve these forces, this RD is going like this. So this is the horizontal component. This is the vertical component. Right. So this angle is theta. That means this angle is theta. The side which is nearer to the theta is cosine. Right. So this is RD cos theta and this is RD sin theta. Okay. So now next step is we are going to apply equilibrium equations to this sphere. So sigma fx equal to 0 and sigma fy equal to 0. Right. So in considering sigma fx, here we have RD sin theta which is to the right side. So RD sin theta is positive. Then RC is to the left side. So RC is negative. It's equal to 0. Okay. This is one equation. Then second we are going to consider sigma Fy equal to 0. So sigma Fy means sigma Fy, we have a vertical component RD cos theta upward, so it is positive. Then 1000 Newton is downward, so it is negative, equal to 0. This is equation number 2. Look, there in this second equation we have only one unknown, that is RD. So from this we can find out RD. RD is equal to 1000 divided by cos theta. Theta, what is theta here? 53.13. So cos 53.13. Solving this, we will get RD as 166.66 kilonewton. Okay, so we got the value of RD. By substituting this value in this first equation, that is RD is 1666.66. By substituting that in the first equation, we will get RC as such. Therefore, RC is equal to 1066.66 into sine 53.13. We will get RC as 133.32 kilonewton. Okay, so we will get the value of RD as well as RC. Okay, now we need to find the reactions RA and RD. So we are going to the first sphere. Okay, we are going to consider the first sphere. So this is the free body diagram of a sphere figure. So we are going to again applying equilibrium equations here. Sigma fx. Here sigma fx, if you apply sigma fx, the sum of horizontal components. What are the horizontal components here? RA, which is acting to the right side. Then RD. Here also RD. We need to resolve RD. Okay, this angle is theta. So definitely this angle is theta. So this component is RD cos theta and this component is RD sin theta. So here horizontal component is minus RD sin theta because the component is acting to the left side, equal to 0. So we already know the value of RD from the second sphere, right? It is 1666. So from this figure we can find out RA. RA is equal to RD is 766.66 into theta is 53.13. So from this we will get the value of RA as 133.32 kilonewton. Okay. Now only one unknown is there, that is RB. To find RB, we consider the equation sigma Fy equal to 0. So sigma Fy equal to 0 means RB upward direction positive minus RD cos theta downward direction minus 1000 equal to 0. We already know the value of RD and 1000. So we can find out RB. RB is equal to RD is 166.66 into cos 53.13 plus 1000. So we will get this as 199.99 kilonewton or 2000 kilonewton. Okay, so we find out all the reactions RA, RB and RC. RA, RB and RC. Okay, this is how we solve a free body diagram problems. First, we need to isolate the body. We have to mark all the reactions and forces acting on that body. Then if there is an inclined force, there should be an angle, so we have to find that angle. That angle we can find some, some details are already there in the question, so just mark that dimensions when we get the angle. Okay, so then find the angle and substitute, apply the equilibrium equation, sigma fx equal to 0, sigma fa equal to 0, then solve the equations, we will get all the reactions. Okay,